and then we will begin. And I don't know if you guys have your follow along, but it doesn't matter. So I just wanted to share the follow along with you. Here it is. Okay, so this is what I want to do. And you guys can all see this?
Yeah.
Okay, you can all see it clearly. Everybody can see what it is? Good. I want to know. Answer that question. What's the difference between those two functions? Okay, so what's one thing you can tell me about these? Like, what kind of functions are they? What kind of functions are they?
Exponential.
Of course they're exponential, right? So they are exponentials, and it looks like they both have a base of 2. It looks like that, doesn't it? Yeah. What looks like that's a little bit different about the two of them?
One has -1 in the exponent, and one has it not an exponent.
Yes. So, right. Now, if I asked you to find the y-intercepts for both of those, what would you get for your y-intercept? How about this? If your last name goes from A through K, I want to know what the y-intercept is for f of x. Everybody else, I want to know what the y-intercept is for g of x.
Should we say it when we find it?
Yeah, if you're ready. I want f of 0 and I want g of 0, right? So for f of 0, what do you have here?
3 halves.
3 halves.
3 halves.
And what do you have for g of 0 here?
2.
2. Okay. So if I were to ask you, we know that these are exponential functions. We all agree, right? Which means they're going to have an asymptote, a horizontal asymptote. If you had to guess, where is the horizontal asymptote the same through for f of x? And for g of x, where do you think your horizontal asymptote is?
-1.
Who's, are you talking about g of x? You're saying your horizontal asymptote is y is equal to -1 here? Aaron, is that your call? Okay. And then people over here, what do you think your horizontal asymptote is over here?
X-axis.
The x-axis, so it's y equals 0. Exactly.
0.
It is. It's definitely going to be that. And we can even go to, of course, my favorite, you know. We'll go to Desi's, right? And hit my share button. And did anybody get in touch with George yet?
I texted him.
You did? Okay. Is anybody else missing that that you're all checking out to see? Because I don't know if everybody is here 100%. So what is this? Did I say 3x minus 1? Minus 1. Okay. Whoops. No, stay as an exponent. Minus, I don't know why it doesn't want, here we go.
To do parentheses in the exponent.
Is that what it is? How about if I do -1 plus 3x? I'm going to get away with that if I do them plus 3x. Okay, so here we go. there's that, right? We have this one, and then it should all be raised to the power there. Okay, so just feel comfortable, and then d of x I said was equal to 3 times 2 to the 3x, right? Close that out, and then minus 1, right? And so if we were to look at that, you can all see that, you know, that we have it where you can, if you were to draw the line y equals 0, and if you were to draw the line y equals -1, that you could actually see that they are asymptotic to those things. So it's just kind of moving along, right? And you go along here, it's all good. Now, what I want to do is I'm going to go back here, here, and go back to this over here. And I want to go to this one over here. So I want to know, this is the claim that Michael claims that this function f of x and g of x are the same function. And I want to know, is he right? Is he right? So your job is to figure out if they are the same function. Okay, so are they the same function, yes or no?
Yes.
Yeah.
Yes, so everybody agree that it's yes?
Yeah.
Because check it out, right? If you use your laws of exponents, and I'm going to go over it for those of you who are like, I'm not sure. If you take f of x and you rewrite it, you can take this. Can you guys mute your thing? So where you guys are, just mute your, because the back thing is killing me. So when you have 2 to the 3x, you can write it as 2 to the 3x times 2 to the -1 using your laws of exponents. Because the beautiful thing about laws of exponents is if you have a to the x plus y, you can write it as a to the x times a to the y, or vice versa, depending upon how you want it to work in your favor. So the first thing I notice is that I can break it down into these two things, and 2 to the -1 is equal to 1/2, right? That's what 2 to the -1 is. So I have 3 times 2 to the 3x times 1/2. So I currently have 3/2, because I can multiply this times 2 to the 3x. Now this right over here is cool, because if I have 2 to the xy, I can write as 2 to the x raised to the y power. So therefore I can go ahead and rewrite this as 2 cubed to the x power, which is in fact 3/2 times 8 to the x. You all with me on that?
Yep.
So in fact, it does work out beautifully that they are the same function, and that's using our laws of exponents, which is kind of cool. Okay. All right. I skipped 3 and 4 on the packet because I want you guys to figure that out without me. But what I'm going to do is this: let's say that you have like h of x is equal to, throw a number out at me.
7.
Sure, you and your 7. You love your 7s. Okay. And let's say that we have 1/3 to say the -3x power. How can I rewrite that, just out of curiosity?
7 times 1/3
9
to the negative third times.
-3 and then to the x power, yes?
Yeah.
What is 1/3 to the -3? What is 1/3 to the -3? How can I rewrite that, everybody?
3 to the third.
3 to
2
the
to the
third
third.
power, right?
27.
This is the same thing, yeah. So therefore, h of x is equal to 7 times 27 to the x power. What's the base of this function?
27.
27.
Holy crap. If our money grew like that, guys, we would never, ever, 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 ever have to work. Even if you started with $7, look at that. It's growing at 2,700%. Woohoo! I'd never have to work again. All right. You like that? Okay. All right. So let's say that that I'm giving you this function, a little cutie patootie function, h of x is equal to the x power, and I ask you to find the inverse. Do you knuckleheads remember how to find the inverse of a function?
You switch x and y.
You do. You switch x and y. So we start off by rewriting this y equals 2 to the x. Thank you, Sonia, who said you switch x and y, and then you solve for y. So if
Don't you
I
also have to restrict the domain?
what'd you say?
Don't you also have to restrict the domain?
That's if only it doesn't pass the what?
Oh, the
What
vertical
test? What's yes?
Vertical.
So in other words, so this is y equals 2 to the x power right here. Yeah. Does that pass the horizontal line test? Anyone does this pass the horizontal line test? It does.
Yeah.
So therefore, do I have to restrict the domain of my exponential function? No. Good. And then if I said to you, what is the domain of this function? What would you tell me? F of
X is all real numbers.
X is all real numbers, and then your range is y is
Y is greater than
it's got to
0.
be greater than 0 because it's going to be trying to, because if you do 2 to the negative first, it's a half, 2 to the negative 2 is a 4, 2 to the negative third is an 8, 2 to the negative fourth is a 16th, and so forth. So those numbers are trying to approach 0 but never get there. So now I want to know, what does his inverse look like? Okay, so if I were to ask you guys, do me a favor, before we actually find the inverse, I want you to sketch the inverse. All inverses reflect over what line?
Y equals
Y
x.
equals X.
It does. So, and I know then that if the point 1 comma 0 is on my original function, then what point is going to be on the inverse?
1 comma 0.
1 comma 0. So I know the inverse contains the point 1 comma 0. The other thing I know about the inverse is what happens to the domain and range.
They switch.
They switch. So, right, because if x and y switches, don't the domain and ranges switch? So if I said to you, what is the domain of the inverse we're going to get our hands on, what are you kids going to tell me?
Y x
Y
is greater than 0.
or X is greater than 0.
And then your range is?
All real numbers.
All real numbers. So now if I ask you guys to reflect this pink curve over this line, what does it look like? Using the fact that you know the domain is x is greater than 0, and then your y values are all real numbers. Why don't you knuckleheads see if you can go ahead and sketch that, what you think it's going to look like. And then what I'm going to ask you to do is actually hold it up on your screens, because I'm going to stop sharing for a second and see what you knuckleheads come up with in terms of what the sketch is going to look like. Okay, so everybody is going to sketch what they think that the inverse is going to physically look like graphically, and then we will actually find it algebraically. So I'm going to stop sharing for a second, and when you think you have it, hold your pretty pictures up to the screen, because I'm just curious as to what you knuckleheads come up with. Hold it closer. Hold it closer. Jolie, I like yours. Good. Is that Nora? Yes, Nora, good. Yeah, where's your asymptote at, friends? Where's your asymptote
Y equals
at?
0.
Y equals 0, so you should not be crossing y equals 0, right? So for those of you who made it cross, it shouldn't have crossed, because remember, we said that the domain is x is greater than 0, right? So we know that the domain is x is greater than 0, and so therefore it's going to it's got to be greater than 0, so it's going to be asymptotic this way, whoops, and it's going to look something like this, okay? And then we'll even confirm that on Desmos. So now, this, we know the inverse of an exponential function is a, what's the inverse of an exponential function, everybody? Logarithm. So now let's go back over here. So we have x is equal to 2 to the y, because we switched x with y, and now our job is to just simply solve for y. So to solve for y, we're going to just rewrite this in what form?
Log form.
Log form. So it's going to be, can somebody tell me what it is?
Log of 2.
Say log base 2.
Log base 2 of y equals x.
Careful.
Or of x equals y.
Right? Remember, you guys, if I have y equals just a to the x power, how do I write that as a log?
Log base a equals y to the x.
So we do log base a of y is equal to x. This is how you would rewrite that, yeah?
Yeah.
How you go from exponential to log form. So the same thing is going to happen over here. So in other words, we're going to do log base 2 of x is equal to y. So therefore, the inverse is going to be equal to log base 2 of x. So the inverse of 2 to the x is log base 2 of x. So again, we'll go to my favorite friend, my little buddy, Desi Des. Okay, we'll go to Desi Des, just share, go back over here. And then this time, we'll just, hold on, let me go to this guy first. And go over here, shut. And we have 2 to the x power, so we have y equals 2 to the x power. And then we have y equals log. Do they let me do the little shenanigans here?
Yeah, you go to functions. Yeah.
It's under functions, right?
Mhm.
Here it is. Okay. So log, what I want the base, where do I get my base in here? Is there a way to do a little base in here?
Go back to the functions. There's one where there's log and then a.
Oh,
Yeah,
here.
in the bottom.
There it is. Thank you. So log base 2, thank you very much, you guys. Okay, of x. And there it is right here. So now if you look at it, you can actually see that if I were to draw that line again, that y equals x, sure enough, it's going to work. And then if I pick a point over here, this point is going to be, it'll reflect over that line. So you can see that the exponential function is asymptotic to y equals 0. And then this log function, its inverse is asymptotic to x equals 0. So I think that that's kind of cool that you can actually see how those are going to look. Okay. So now let's go back to, okay. All right, now I got to do this again, do the new share. If I hide that, it doesn't let it come up, but we got it now. Okay, so thank you for your patience. So now right over here, it says, given that g of x is log base 6 of x, we want to find the inverse. Huh, interesting. So if I were to talk about log base 6 of x, what would be the base of the inverse?
6.
6. Yes, look. This is log base 2, so his inverse is going to have a base of 2. This is log base 6, so therefore it's going to be the same thing. So what we're going to do is, because we know we can go back and forth, we're going to start doing that where we actually go back and forth. So according to my friend Sonia, she said if you want to find the inverse, you switch x with y. And now how do I write this in x? How do I solve for y here? So in other words, if I'm in log form, I could always go back to exponential form. If I have exponential form, I can always go back to log form. That's what's beautiful about the inverses of these two. How does this look if I wanted to solve for y? What would it be? How do I write this in exponential form? I guess I'm just going to call on somebody. Ashan.
What x is or way we want to solve for y is equal
We're
to
solving
x
for y, right? So this is in log form, so which means I'm probably going to write this in
exponential form.
So what is that? If you
X
look
is
over here, right? If you look over here, you see how it has log base a of y equals x. We're doing a to the x equals y, which is this guy right above it.
X is equal to wait.
I'll give
6
everybody
to the x. Y is equal to 6 to the x.
Everybody a second to take a look at that, okay? Give everybody a second to look at that, and how would you rewrite that? Okay. Well, you got it, Ashan?
Is it y equals 6 to the x?
Yeah, because you can do 6 to the x is equal to y. So 6 to the x is equal to y. So therefore, the inverse of that is going to be 6 to the x power, right? So if you look at this and you look at this, these two functions are inverses of each other. 2 to the x and log base 2 to the x are inverses of each other. So what if I had, for example, h of x is equal to 3 to the x? Could you predict what the inverse would be for that one? And I'm going to do k of x. Give me a number from 1 to 10.
7.
Sure. Okay. I want the inverses for those two. So in other words, if h of x is equal to 3 to the x, what is his inverse? If k of x is log base 7 of x, what is his inverse? And I wait for you guys to do it. So how about, no, everybody's doing both. Everybody's doing both. And then, oh my God, time. What time is this class? Okay. I got a whopping 6 minutes left. Great. Okay, who has the inverse for 3 to the x?
Log 3.
Make sure you say the word base. Log
Base
Base
3.
of x, good. And then log base 7 of x, the inverse of that is?
7 to the x.
7 to the
7
x.
to the x power. Awesome. Okay. And then you could, again, if you graph these on Desmos, I guarantee they're going to look something along the lines of this, because these are like the parent graphs. These are cutie patooties before we start adding things to the exponents or we start changing things up on the x's. So always, you know, these are all of the exponential functions here at this point are asymptotic to the x-axis, and all the log functions are asymptotic to the y-axis at this stage of the game. But then we're going to make it juicy. So what I mean by juicy is moving on to something like this. Okay? Do we all see that this is, in fact, an exponential function? Do you all see that this is who's the base of this function?
5.
It's a 5. Good. So now if we want to find the inverse, again, we're going to switch x with y. So we have x is equal to 2/3 times 5 to the x minus 4. I'm sorry, y minus 4, forgive me. Y minus 4 power. Okay. I'd rather you guys just watch and then plus 3 over here. So again, we switch x with y and we solve for y. So what's the first thing we're going to do, friends?
Subtract by 3.
We're going to subtract 3 from both sides, exactly. So we have x minus 3 is equal to 2/3 times 5 to the y minus 4 power. What's the next thing we're going to do?
Multiply by 3 halves.
Multiply both sides by 3 halves, exactly. So we're going to multiply both sides by 3 halves. Right? We have 5 to the y minus 4. If we tidy this up a little bit, this would just be 3 halves x minus 9 halves is equal to 5 to the y minus 4, right? So right now we are in exponential form, but we're trying to solve for y, so we have to turn this into log form. So if I have y equals a to the x, let me just do this again, I keep doing that. So if I have y equals a to the x, come on, Shark. Thank you. Y equals a to the x. I know I can write this as log base a of y is equal to x. This is the log form of this exponential form, right? So if I come down here, can you guys tell me how I'm going to rewrite this in log form? Can somebody, I'm going to call out to someone here. Okay. Nora, can you figure out how we would rewrite this in log form?
It would be log base 5 of 3 halves x minus 9 halves equals y minus 4.
Okay, awesome, blossom. And then the last thing we need to do, friends? What's the last thing to solve for y here, folks?
Add 4.
Add 4. Good. Minus 9 halves plus 4 is equal to y. So therefore, if this is h of x, h inverse of x is going to be equal to log base 5 of 3 halves x minus 9 halves plus 4. Okay? Now, if we go ahead and we plot these two on Desmos, what line will they always reflect over?
Y equals x.
Damn right they will, okay? So I have 2 minutes left, so I am going to jump. We're going to find the invert. And what I want you guys to do is go back and actually plot these two on Desmos just to confirm that my math is correct, okay? So you guys are going to plot those on the Desis for me. And then finally over here, we're going to do this problem first. I'm giving you a log, which means its inverse is going to be what kind of a function?
Exponential.
It's going to be exponential. Good. So again, we're going to switch x with y. So we have 4 times log. And by the way, what's going to be the base of that exponential function?
3.
3, because this is log base 3, right? Oh,
Three.
that would be a y there. Sorry, this is a y here. Okay. All right, so this is y. Okay, step 1. Here we go. What do you want to do first?
Add 5.
Add 5, and then
Divide by 4.
5 by 4.
divide by 4. So we're going to add 5 and divide by 4. So we have x plus 5 divided by 4 is equal to log base 3 of 2y plus 1. So right now, this is in log form. And again, I'm going to go over here. We have log base a of x equals y, meaning that you can rewrite this as a to the y is equal to x. If I asked you to convert this to exponential form, let me go to Jolie. Jolie, can you tell me how I would rewrite this in exponential form?
So log. Hold on, sorry.
That's okay. So I have log base a of x equals y, which I can rewrite as a to the y equals x.
So it would be
I'm gonna rewrite this
3,
one. One more time.
3 to the x plus 5 over 4
Beautiful.
equals 2y plus 1.
Good. So that's how we go from log into exponential. And now what's the last thing we need to do here, folks?
Subtract 1.
Subtract 1 and
Divide
divide by 2. Good. So we have 3 to the x plus 5 over 4 minus 1 all over 2 is equal to y. So this right here represents g inverse of x. So g of inverse of x is this crazy looking, beautiful exponential function. And again, I strongly suggest that you take this and plot it with this on Desmos, and I guarantee they will reflect over that beautiful line, y equals x. Okay? If you want to do me a favor, actually, you know, I will let you know what I want you to do. I think, what is that, number 7 and 8? You have to show that they show Desmos on that. So, and I'm going to also have you guys do numbers 3 and 4 and 9 on your own time. I'll give you a due date for those, okay? But so let's go to stop sharing because we are essentially out of time. But I just wanted to get us started on finding the inverse of exponential and log functions because they do work hand in hand. It's kind of like when I would give you a square root function and a parabola and say find the inverses. Now we're just going to start getting our feet wet on all of this stuff as we go along. Okay? All right. So I'm going to hit stop recording.